This is the homework for Paul McWhorter's lesson number 48. He asked us to incorporate the, what do you call that thing? Let me look, gyro information with the accelerometer information. So here's the program. I'll start with that. I import math, time, all the stuff for the display. Then I have a function here to draw the little circle that's part of your level. And then here's some more information for the display. And MPU 6050 is also I2C. So we got, here's where I do the function for the circle radius in the center of the display. Okay, then I put a bunch of variables I have to define. And down here, this is where we start the ticks, where we can time the gyro stuff. Okay, down here, here's why I take my accelerometer data, and here is the math involved to get the degrees for your accelerometer data. And I also put in the low pass filter to help minimize how much that moves around. Okay, and then there's the pitch and the roll. And down here I get the gyro data, the X, Y, and the Z. And let's see, what have I got here? Here I take the roll and I round it, just because it becomes too many digits to really be useful. And then I take this information, the roll, and then the roll, I got the roll error equals the roll minus the roll degree average. And this roll is the gyro information, and this roll is the accelerometer information. So then I take it, then I round it. That gives me the nice display for it. And then the pitch is the same thing. I round it so I can see something that you can actually see. Okay, then the yaw degree, this here changes it to the degrees from the radians, and basically the same thing. I've done the low pass filter, I've done the reading, and here I make the error reading, the yaw minus the accelerometer information. And then I take the yaw information here and I subtract that error that developed up there. Now down here we got where I set up the display for the rectangle, the horizontal line, and the vertical line. The pitch, they got a pitch old equals pitch degree, and then roll degree old equals roll degree. That's so you can do the low pass filter stuff. Okay, down here I've got the circle. It's a radius of 6, and I've kind of scaled it a little bit so that it doesn't move too fast. In fact, I had to cut down the roll because of the rectangle so narrow for that. Okay, now here's our display. I've set up a what do you call it? A formatting thing. So I just print this, it becomes that, and it gives me a nice formatting on the display. Okay, now then we get down here, we show it at fill 0. If you don't do that, you get little circles all over the thing. And stop time.ticks, that gives you the information so that you can get your gyro information. Okay, let me go up here and we'll run this guy. This took me a while to do this thing. There's probably a lot more elegant ways to do it, but I pretty much do brute force everything. Okay, here it's going. Right now you can see that, I don't know if you can actually see that. Let me stick something underneath it to raise it up, because this camera doesn't go down. Try that. Okay. Now I think you can probably see it now. Maybe I gotta bring it up a little higher. Let's turn the box sideways. There we go. How about that? Is that a little better? Okay, so if I tip it like this, it doesn't go off the screen like it did before. Tip it like that, and you get the thing to deflect the opposite direction. And this one doesn't. I cut it down so it doesn't fly off the screen either. Now, if I go like this, you don't get as much of that deflection because you're averaging out with the accelerometer data. And there's my homework, Paul, and I appreciate you doing these. Thanks.